How is it that scientists are able to find the age of ancient tools from prehistoric humans or the age of old cave paintings? The answer is carbon dating. All living things contain carbon in them. Now, there are different types of carbon: carbon 12, carbon 13, carbon 14, etc. Different versions of the same element are known as isotopes. The number beside their name means how many protons and neutrons they contain added together. Different isotopes of the same element will have the same number of protons, but a different number of neutrons. For example, carbon 12 has 6 protons and 6 neutrons, while carbon 14 has 6 protons and 8 neutrons. But carbon 14 doesn't want to have that many neutrons because that makes it unstable, so it undergoes beta negative decay and becomes nitrogen 14. Beta negative decay is where one of the neutrons in the parent atom turns into a proton and then also releases an electron and an antineutrino in the process. On average, it takes about 5,700 years for half of the carbon 14 in a group to become nitrogen 14. This is known as the half-life. All living things contain the same ratio of carbon 12 to carbon 14. But once that organism dies, it stops getting carbon from the atmosphere, and any carbon 14 left in it will eventually be replaced with nitrogen 14. Scientists can measure the amount of carbon 14 that should be in the organism versus how much is actually in it. And using the half-life, they can date the age of the organism. Unfortunately, scientists can only date accurately back to about 50,000 years ago, because after that there is too little carbon 14 for it to become accurate. But where does carbon 14 come from, and why is there so much in the atmosphere? The answer is cosmic rays. High-speed particles from the sun, and even from outside our solar system, come into Earth's atmosphere. These particles are typically protons or alpha particles. They're known as cosmic rays. If the cosmic ray hits an atom, it'll cause the atom to break apart into tiny subatomic particles. Sometimes these particles are neutrons. If these neutrons run into a nitrogen 14 atom, the following reaction will occur. Nitrogen 14 plus 1 neutron equals carbon 14 plus a proton and some energy. So the nitrogen atom exchanges a proton for a neutron. This happens in our atmosphere constantly, and eventually these radioactive carbon atoms get consumed by a plant or an animal and becomes part of that organism. Any organism can be dated, as long as it contains carbon. That being said, dinosaur fossils and other ancient organisms are unable to be dated because there is too little carbon 14 left in it. Typically, carbon dating is accurate up to about 50,000 years. If you would like to learn about how scientists date back dinosaur bones, watch my other video that should be appeared on the screen right now.